Find the indicated IQ score. The graph to the right depicts IQ scores of adults, and those scores are normally distributed with a mean of 100 and a standard deviation of 15. So in this case here, what we're given is the area. So this is the area. And so when we're given the area, that means that the mean currently right now is 0, because that's on the z-scale. Okay, and what we want to do is we want to locate what this score is, which is what we want to find for z. Now, we also know that below that is going to be the x scale, which represents the IQ scores. Okay, so the mean for the IQ scores here is 100. And so then eventually what we want to do is we want to find out what is that value of x that's here. But we first need to find the value of the z-score. Okay, so we want to find the z-score that corresponds to an area of 0.45. And if you notice here, this is to the left of that. So what we're looking for is, okay, what is the probability of a z-score that's going to be less than or equal to a value that's going to give us an area of 0.45. So what we're going to do is use StatCrunch to find that z-score. So let's go ahead and open up StatCrunch. So we go to Stat, Calculators, and scroll down to Normal. Okay, now we want our mean to be 0 and our standard deviation of 1 because that's what the scale is here because we're given the area. And over here, we want to make sure the less than or equal to, but don't put any values over here because the bottom right is where we put the area. And the area is going to be 0.45. And then we're going to select Compute. So we're going to go ahead and select Compute. And let's take a look at that. So here you can see we get a z-score. We're going to round that to 2 decimal places. It's going to be negative 0.13. So this should be negative 0.13. Now, since it's to the left of 0, that looks like it's correct. So therefore, z being less than or equal to negative 1.3 gave us that area. And now what we want to do is we want to find that value for x. Now that we find our z-score. Okay, so since the z-score is negative 0.13, now what we're going to do is we're going to convert a standard normal random variable z to a normal random variable x by using the formula below, where the mean is where mu is the mean and sigma is the standard deviation. So there is our formula. So now what we're going to do is we're going to plug the following values. We're going to take our mean, which is 100. And then we're going to plug in the value of z, which is negative 0.13. And then we're going to plug in the standard deviation over here, which is 15. And then we're going to simplify. So if you take a look here, again, using the values of the mean of 100, standard deviation of 15, and the z is negative 0.13, we're going to plug it in there. So we get 100 plus the value of z, which is negative 0.13, times 15. So remember, order of operations, we take negative 0.13, multiply it by 15, and then add 100, and we get the value of 98.1. So therefore, if we look at our graph, that means that here, this x should be 98.1, which is right below the 100. So therefore, the indicated IQ score is 98.1.